Hello, welcome to the video on simplifying by combining like terms. Let's take a look at our objectives of this video. First thing we want to do is go ahead and identify the parts of an algebraic or variable expression. Then we want to go ahead and understand how to combine like terms. And then we're going to simplify variable or algebraic expressions. So probably a lot of terminology in here that you may not be familiar with, but don't worry, we're going to clear that up in just a second here. So let's go right to it. Let's take a close look at an algebraic, and another word for algebraic that's often used is variable. Okay, so let's take a look at an algebraic or variable expression, right? And I want you to think of an algebraic or variable expression as a sentence in algebra. Okay, so if this was an English class, and I said let's take a look at a sentence, you would expect to see words and some punctuation marks, maybe some commas, quotes. And same thing in algebra. Okay, so this is an example here. I have 4x squared plus 2x minus 1. Think of this as an algebraic sentence. So let's take a look and identify the main parts of this sentence or expression. All right. The first thing is, let's start with this word here, term. Okay, a term is where you have a number being multiplied by a variable. Okay, so you can see here you have 4x, and when you have a number written right next to a letter in algebra, like this, 4x, that means 4 times x. So anytime you have a product of a number and a variable in algebra, we call the resulting expression a term. All right, so this right here is a term, 4x squared. But however, in this entire sentence or entire expression, it's not the only term. All right, can you pick out the other one? Right here, 2 times x, or 2x is another term. So this particular expression has two terms. Now why is this right here, and this is -1, why is that not a term? Well, this is kind of a technical thing. Sometimes technically this is a term, but we more commonly refer to this as a constant. Okay, so that brings us to our second word that we're looking at here. So a constant is essentially a number. Right? 1 could be 10, 9, it could be a decimal, it could be a fraction. So anytime you have just a number, a real number of some sort, involved in an algebraic expression, we're going to refer to that as a constant. Right? So this is a term, 4x squared is a term, 2x is another term. Now, one thing I want to stress here is that terms in an algebraic expression are separated by addition and subtraction operators. All right, so that's a good indication of where your terms are at. They're going to be separated by plus or minus signs. Okay, let's take a look at our last keyword here, and that's coefficient. That's how you say that word, coefficient. And coefficient is the number in front of the variable in a term. Okay, so 4x squared, when you have a 4 in front of this x squared part, the 4 we would refer to as the coefficient of that term. All right, so if I asked you what's the coefficient of 2x, you would say, correct, you would say 2. Okay, because 2 times x makes up the entire term, but the number part of that term, or the number in front of the variable, is the coefficient. All right, so let's go down. Let's take a look at something called like terms. Okay, so we talked about what a term is. It's a number, for example, multiplied by a variable. Okay, so that's a term. So what's a like term? Right, well, here I have some terms I have listed here, and under over this quote here, I'm saying these are like terms. So why don't you take a second here and see if we can identify the pattern. Why do you think we're calling these like terms? All right, so the hint here is, what do they all have in common? So let's take a look at this first one. Here we have x, x, and x. So all these terms have an x. Now, by the way, you're saying, well, this particular one, this x by itself, doesn't have a number in front of it. Well, actually it does. Okay, it has a 1. All right, but in algebra we rarely write a 1x. I don't want to say rarely, but more often or not, you'll see it as x. Okay, so if I wrote y, okay, that's the same thing as, say, a 1y, all right, or any variable. So these are all terms. Now notice they all have x's in them. All right, so if you say, well, they all have x's, they're all terms with x's, that makes them a like term. Well, if you said that, you would be 1/2 correct. All right. Now let's take a look at this particular example. Now these are all like terms also, and they all have y squares involved in them. And this is a 1y squared, by the way. So I'd say, well, yeah, they all have y squares, and you would also be correct. But the key here that I want you to pick up on is that for terms to be like, they all have to have the same variable, but this variable needs to be to the exact same power. Okay? So here, this is x, x, x. Really, they're all to the x to the first power. All right, so let me just kind of demonstrate this by a counterexample. Say 6x and 4x squared. All right, so if you said, oh yeah, if they both have x's in them, they're like terms. Well, no, that's not true. They both have to have an x, the same variable, but they also have to have the same power. Okay, so this is x to the second power, and this is x to the first power. All right, so these would not be like terms. Okay, not be like terms. Let's look at one more example. Let's say we have 8y squared up here. What if I had negative 2y? Okay, so this is y squared, this is y to the first power. They're close, but close doesn't cut it here when we're talking about like terms. Okay, let's do one more example. What if I had negative 2y and negative 2y squared? Now these look really similar, very much alike. They both have a negative 2, they both have y, but guess what? Still, they're not like terms because the focus here on like terms is they must have the exact same variable to the exact same power. Okay, we're not looking at the coefficients. So let's go ahead and practice what we just learned here and identify the coefficients, terms, and constants and like terms here in these expressions. Okay, and they're all separated by commas. So let's start off by just identifying terms. All right, so let's see here. 2x is a term because it's a number being multiplied by a variable. Okay, 4a squared is also a term. This would be negative 1x. Okay, negative 1x. Okay, that's a term. That's a term. 3y. Negative 7x is a term. Negative 5a squared is a term. And 9 here we would refer to as a constant. All right, so those are all our terms and constants. Now let's go ahead and take a look at our coefficients. All right, so now coefficients are the number that is in front of a term. All right, so here 2 is a coefficient, 4 is a coefficient. Here negative 1 is a coefficient, 3, negative 7, and negative 5. Okay, those are all coefficients. All right, so let's see here. We did this. We identified terms, constants. We identified 9 as a constant. Now let's take a look at like terms. So what you have to do here is go look for all the terms in this list that have the exact same variable to the exact same power. All right, so let's go ahead. Let's take our time here. I have an x to the first power. So is there anything here that has an x to the first power? Yes, this one does. Negative 1x. That's negative 1x to the first power. And negative 7x. All right, so those are all like terms. All right, you understand that? Okay, how about 4a squared? Let's use a different color. Is there any other a squares here? Yes, this is negative 5a squared. Okay, because they both have a squared, these two here, these two terms would be considered like terms. All right, so let's see here. That leaves us with 3y. Can we match up with 3y with anything? No. So 3y doesn't have any like terms as far as these examples or these list of terms go. All right, so let's go down here. Let's kind of practice this again. Well, maybe you already got this, but it's good just to practice this. Make sure you really understand this. It's extremely important. Okay, so term, 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 constant, and term. Okay? All right, they both have a coefficient and a variable. That's what makes them a term. All right, so let's go ahead and now identify. We're going to identify the coefficients. 4, 4, 9. Here there's a 1. Okay, here there is a 1 in front of that z. Z squared, actually. All right, so let's go ahead and identify like terms. We'll just go ahead and start with the z squared. Z squared, I'm looking for another z squared. Boom. So 4z squared and 1z squared are like terms. Okay, notice I skipped the 4z because it's not z squared, it's z to the first power. All right, so let's take a look at 4z. Is there any more z's here? No. So this one doesn't have any like terms. 9x squared, is there any other terms with an x squared? No. And is there any other terms with an x? No. Okay, so here the only like terms were the z squared terms. All right, so let's bring us to our last example here in this particular set. Now you're saying, well, I can't really identify what the terms here are. Okay, this is written kind of funny, and you would be correct. Okay, this is a distributive property situation, so how can I identify what the coefficient or terms are? Well, this is going to bring it to a real key point here in a second. In order to see terms and coefficient clearly, very clearly in expressions, you must apply the distributive property if you're in a distributive property situation. So let me just go ahead and show you here. Let's go ahead and apply the distributive property to this expression here. I'm going to get negative 3y plus negative 6. And if you don't understand that, you want to go ahead and go back and take a look at the distributive property. So I have 4y, I have 10. Here I'm going to have 2y minus or plus a negative 10. All right, so now I have all these numbers and terms. Now, once I've done the distributive property, now I can clearly identify what's going on. So I have 3y is a term, 4y is a term, 2y is a term. And by the way, they're all like terms. Okay, they're all like terms. It's all y to the first. Right? And also, you can see here, I have negative 6 as a constant, 10 as a constant, and negative 10 as a constant. All right, so if you master that, we're ready to go ahead and learn something called combining like terms. And combining like terms is pretty much what it sounds like. It's when we have like terms, you can add the coefficients and put two like terms and make them into one. So what am I talking about here? Let's take a look at our first algebraic expression. We have 4y minus 8y plus 6. Well, notice that 4y and negative 8y are like terms. Right, this is plus negative 8. All right, so therefore, when you have like terms, you can add up the coefficients and just write it as one term. So 4 plus negative 8 is negative 4, and they both have y, so it's negative 4 plus 6. Okay, so you can write negative 4 plus 6 instead of writing this. Okay, and we want to do this in algebra. We want to be able to combine like terms. It's a real basic skill. Let's go ahead and do another problem here. Give ourselves a little bit of room. Okay, so the first thing is we have to identify what like terms are. So let's see if we can identify the like terms. All right, so you have 5x, that's a term, this is a constant, and this is a negative 1x. All right, so those are like terms. All right, same variable, same power. So we're going to go ahead and add the coefficients. 5 and negative 1 is positive 4. So it's going to be 4x plus. Now one thing is when you're combining like terms, remember I said constants are kind of like a term? Well, the thing is when you're combining like terms, you're allowed to go ahead and just add up those constants too. So instead of have 5x plus 10 minus 1x plus 2, we're going to go ahead and add up this 10 and 2. So we simplify this whole expression and make it easier by just saying 4x plus 12. All right, that's a key concept that I want you to take away from this lesson, is that we're just trying to simplify these algebraic or variable expressions by combining these like terms. Okay, why don't you go ahead and try this one here. Okay, first step is to identify the like terms. So let's see here. This is a term. I'm going to start looking for things with t squares in them. Okay, 9t squares. Do I have any more t squares? Here's one. All right, so I'm going to combine those two together. So I'm going to combine the coefficients. So 9 and 2 is 11. 11t squared. And it's a good idea sometimes just to put one little line through your expressions just like this, just so you can kind of keep track of them. All right, so now let's take a look at negative 4t. Let's look and see if there's any other like terms with t's involved in them. And see here we have one. Okay, that's 1t. So I'm going to add the coefficients. Negative 4 plus 1 is a negative 3t. All right, so I'm going to go ahead and cross cancel those, and then I'm just left with that 10. All right, so let's move on. you now have all the skills to be able to do something called simplifying a variable expression. And what we're going to do here is basically just kind of listing everything we learned here. The first thing we're going to do, we're going to apply the distributive property if we have a distributive property situation. Then we're going to combine all our like terms and combine all our constants. And we've basically been doing this. But now we're going to go ahead and see this a little bit more clearly. Okay, so the first thing I want you to do is apply the distributive property. Now I threw in some couple of, let's give ourselves more room, more challenging problems here. You're going to see in the example sets I do some other easier ones, but let's see if we can go ahead and master this concept right from the get-go. So go ahead and ask yourself, is there a distributive property situation in this particular algebraic expression? Right? Remember, you can recognize a distributive property situation when there's parentheses. So this is a distributive property situation. So we can't clearly see the terms here. Okay, so go ahead and apply the distributive property. So that's going to be x times y, or xy, plus x times 2. Now, if this is confusing to you, you need to go back and take a look at the distributive property video. Now, I'm just going to rewrite the rest of the expression, 6xy plus 5. Now, the next thing you want to do is identify like terms. Now, this is a first example here where we have two variables involved. Okay, and that's okay. You can have as many variables as you like in a particular term, right? As long as they're exact to the exact same power. So this is x to the first times y to the first. This is x to the first times y to the first. So remember, this is a 1 right here. So 1xy and 6xy are considered like terms. Right, so therefore, let's go ahead and add them up. So we have 1 and 6, 7xy. Right, draw a little line through here. Okay, now I have 2x. Is there any more 2x's? No, so I'm just going to write plus 2x, and then I just have that 5. All right. So if you think this is easy, I'm happy for you. And it really is. It just takes practice. It's new for you. You go through the example sets. By the time, I assure you, by the time you go through all of those, you'll have mastered this. But it's extremely important that you understand how to do this in algebra. Okay, so first things first. Any distributive property situations? In fact, there is. So let's go ahead and do that. That's going to be 2x squared. Okay, go back to the distributive property video if you don't understand that. Minus 20x plus negative 6x squared plus x plus 1. All right. Okay, so let's take a look at this first term. Do you have any other terms with x squares? I do. All right, and I'm going to kind of do it this way now. I have a negative 20x. I'm looking for x terms. And this would be my only constant right here. Let's use this color. So let's go ahead and simplify this. 2x squared and a negative 6x squared. I'm adding the coefficients. Negative 4x squared. Negative 20x plus a 1x would be negative 19x. And then I'm just left with this 1. And by the way, a lot of students understand the concepts here, but they mess up with their integers or they don't take their time. So you got to be neat. You got to take your time. Lots going on in these problems. All right, let's go ahead, before we take a look at this review, let's go ahead and do our last problem. So we have a distributive property situation here, distributive property situation here. Okay, now, not every time you're going to see a distributive property situation, but I'm putting in these examples in just so you get the practice. So 3x plus 3 plus 4x plus 8. Okay, we have to do distributive property situation first. Make that x a little bit neater. Plus 7x plus 1. All right, so now let's go ahead and identify like terms. I have x, x, and x. So I'm going to add those up. I have 7 and 7, which should give me 14x. If I did this all right, I think I did. And I'm just left with constants. I have 3 and 8. That would be 11. Plus 1 is 12. And there you go. Okay, so let's review. Terms, coefficients, constants are all part of a variable or algebraic expression. Okay, these are all the components that would make up an expression, right? And it's important that you know this terminology. Okay, like terms have the same variable or variables. Okay, remember like that xy example we looked at. Okay, so like terms have the same variable or variables to the exact same power. They have to be exactly the same. Okay, the coefficients don't count, or the coefficients aren't a part of determining like terms. And then sometimes we need to apply the distributive property to be able to identify terms in an algebraic expression. All right, so if you're confused, go to these example sets, work your way through it, watch the video again, but I'm confident that you'll master this. Okay, good luck.